going to discuss the principle of field of view. Again, you should have been doing some of the reading about this, but based on the angle of inclination, this will determine how much you can actually see with your scope, and it will determine how quickly your field of view changes as you manipulate the direction of the scope. So the first thing to notice, I'm holding my hand still with the camera, and I'm just moving the scope itself. And as you see, this drastically changes what we're looking at despite me holding the camera in the same position. You should also notice that there is a triangle along the peripheral margin of your viewing field. And this has reference to which way your light source is being directed. So if we say, look left, we turn till the triangle is looking left. If we say look right, the same thing, or up, or down. Now if you'll notice, this is opposite the direction of your light source. So this is important. And if you look in the box, you'll be able to see that the light source is at the apex of your angle of inclination relative to your scope. So it just helps you, again, getting perspective, and as you go through the course, you'll be correlating what you see on the screen with how your scope is facing. But this is, again, just to illustrate the field of view concept that you have in your reading. Now, if we change that field of view with a 70-degree scope, we can contrast the two of them, and we see that with our 70-degree scope, again, I'm going to keep my hand centered with the camera, again facing the gorilla, but now as I turn around, I have a central blind spot. And that's because the bend of 70 degrees creates much more of an angle that you can look around. So your field of view is wider. Again, this allows you to look around corners, but you have a central blind spot compared to where your camera hand is facing. Again, this will be illustrated, and you'll do exercises in the lab in reference to this, but this is just to illustrate what you read about.